Welcome to my video regarding confidence interval for statistics. Okay, so in this problem, we'll just read the question. A nurse anesthetist was experimenting with the use of nitrox as an anesthetic in the treatment of children's fractures of the arm. She treated 50 children and found that the mean treatment time in minutes was 26.26 minutes with a sample standard deviation of 7.13 minutes. She wanted to build a 95% confidence interval for the true mean treatment time. What would be that? Show your calculation. Okay, and here she's nice enough to put some additional information, such as the standard error of mean is equal to S divided by squiggly line N. So what does that mean? Okay, so over here we have a standard error of the mean equals S. S is standard deviation. Really, this should be sample standard deviation. Should not be standard deviation. Standard deviation would actually be sigma, lowercase sigma. And the other part, that's actually the square root of n, is the square root of the sample size. So we basically have to do a little explanation over here. So the sample number, or the number of children, would be 50. So in this case, n equals 50. The mean treatment time, the symbol would be x bar. That's called x bar. And over here, we could put down x bar, meaning the mean treatment time is equal to 26.26 minutes. Now, your sample standard deviation of 7.13 minutes. So that would be actually S is equal to 7.13 minutes. And then we have confidence interval. Well, this is really the formula that we're going to be working with. Okay, now over here, here's a confidence interval depends on the value of Z. And actually over here, we really should be using a t-value because we actually have a specific number of samples that we're looking at. We don't have an infinite number of samples, but I think that right now we're using z's. So you have a z table and you have an. So I said here, either you'll be given a table or it will be given to you, or you could use your calculator to look this up. So here is an example of a confidence intervals. So if we wanted to have an 80% confidence interval, we would use the z value of 1.282 and so forth. And for this, you would need either a z table or, like I said, it's either going to be given to you. We're actually going to be working with 95. We want a 95% interval. So what we're going to use over here is, for this exercise, we're going to use z is equal to 95%, and that value is 1.96. Again, either this is going to be given to you, or you'll be given a table, or you'll be able to get that number from a calculator. This is not something that you need to calculate. Okay, so now we want to apply the formula. The formula basically says the confidence interval of 95% is going to be equal to my mean time plus and minus z of 95 times the sample standard deviation divided by the number of samples. So if we put that over here, we're going to write everything down like this. My x bar is equal to 26.9. My z 95% interval is 1.96. My sample standard deviation is 7.1. Now, and my n is equal to 50. Now it's called a confidence interval because interval means that it's between two numbers. And that's why we have a plus or minus. Okay, because it's going to be either one number or another number. We're going to get to this in a little bit. So over here, so now we're going to say that my confidence interval for 95, that should be 95%, is going to be equal to 26.6 plus and minus 1.96 parentheses multiplied by 7.13 divided by the square root of 40. Now, to enter this in the calculator, you have to basically know how to do this operation. So let's just go through an example. So we have 1.96 parentheses 7.13 divided by square root 40. Or you could write it like this, equals 1.96 star, that's usually the multiplication, 7.13 divided by the square root, don't forget to close the parentheses, of 40 and close parentheses again. So here is an example of how to enter this in the calculator. So right here, I actually have a smartphone with an emulator that gives you a TI. Right now I'm using TI 84, but remember this is actually a calculator and you could download this. So let's take a look how we would enter this. We just want to enter the last part right here. So in order to do that, we would do 1.96, sorry, I went wrong, 96. I'm going to multiply that by parentheses, and it's 7.13. And I'm going to divide that by the square root, and the square root you have to do second and the x squared button. So I'm going to hit second, and you know you're on second because that light is flicking upward, and we go right here to the square root symbol. Okay, so it gives me square root, and I'm going to put 40. Now in this, I'm given the option of actually going back like that, but I want to make sure that it's closed, so I'm going to close that up right there. And I'm going to hit enter, and it's going to give me that number, which is 2.2096 and so forth. Okay, so now here is that number, 2.2096. But since we're using two significant figures, we're going to go ahead and round that off to 2.21. Okay, so if I want a confidence interval of 95, well, it's going to be equal to 26.26 minutes plus and minus 2.21 minutes. So if I do that calculation, I know that I'm going to have to do either, it's going to be 26.26 minutes minus 2.21 minutes, and it's going to be 26.26 minutes plus 2.21 minutes. If I do that calculation, so then my confidence interval is going to be between 24.05 minutes to 28.47 minutes. So what does that mean? It means that I want to know what my real mean time would mean. Remember, in statistics, we only have a limited number of samples that we could actually test. In this example, it was 50. And with 50, I'm saying that I have a 95% confidence that my real mean time would be between 24.05 and 28.47. This is what I calculated based on my sample size, but a 95% confidence that the true value is going to be between both of these. Please let me know if you have any questions, and I will go ahead and try to answer them as best as I can. Thank you.